Hello and welcome to episode 11 of PyTorch Code Deep Dive. In the last episode, I was showing how to work with named attributes of PyTorch Module. In this episode, I will show internals of modules forward. If you find presented content useful, don't forget to press the like button and subscribe. I will reuse neural network class from the previous episodes. I removed custom parameter and buffer attributes. There's only flatten and small multi-layer perceptron module left. The module implements forward by flattening input, starting with first dimension, and then generating logits out of multi-layer perceptron. Let's start by defining input extensor. To match first layer of multi-layer perceptron, it has size 28 by 28 with a batch size of 8. I'm invoking module directly. Let's deep dive to see what happens. By default, wrapped call implementation method is called. This is because call method of this class is defined by this method. This method checks first if module contains compiled version of the code. I will skip module compilation in this episode, so as a next step, call implementation method is called. Call implementation checks if tracing is enabled, which is not the case for this episode as well. The forward call is a regular module's forward function. The following if statement checks for presence of local and global hooks. Since none of these are defined, forward method is called directly, passing all provided parameters. As shown before, forward flattens input and then calls perceptron to generate logits. Logits is of shape 10, matching output dimension of last linear layer in the stack. The resulting logits are directly returned to the caller. In the next example, I will register the local forward hook in the module. This hook is a function that accepts the module's object, inputs, and forwards a result. Hook registration creates hook handle first. It passes in forward hooks collections and collections referencing hooks with named parameters and the ones that should be always called. In the beginning, these collections are empty. The handle creates weak reference to the hook dictionaries. It also obtains unique ID. Weak references are also stored for all extra dictionaries stored. Once handle is created, module uses generated ID to store hook reference in local forward hooks dictionary. As our function parameters are all false, no other information is recorded. I will show how it works later. The hook is registered, so let's deep dive into forward again. I will skip to call implementation directly. This time, if condition will not trigger. Result will be kept in a separate variable, and there's a set initialized that keeps called hooks. Again, let's skip compiling. The inner function is called in try except block. There are many types of hooks available, and inner function checks presence of each of these, starting from backward hooks. These were not defined. Then, forward prehooks are checked and backward and full backward prehooks. Only after this, forward is called. The result is captured, and after this, forward hooks are processed. Forward hooks are processed starting from global ones and then proceeding with local ones. There's one local forward hook with ID 1 that was previously registered. As it was registered without always call flag set, it's not added to memo set. As other hook properties were false as well, the hook is called directly with forward inputs as end result. It's important that input is represented as a tuple. Hook can return a result itself. If the result is not none, it overrides forward result. This gives possibility to manipulate forward results with the hook. Backward hooks are called after processing all forward hooks. In the end, final result, potentially modified by the hooks, is returned to the caller. Let's modify hook to check the variant. This time, I will register pre-hook that will accept named arguments. Registration is similar. After obtaining handle, hook is registered in local forward prehooks dictionary. Additionally, as named parameters flag is enabled, it's set in the other local dictionary. Presence of prehook will result in skipping if condition. As there are no backward hooks, we will go directly to forward prehooks loop. This hook accepts keywords arguments. There's obviously no result because forward was not called yet. If hook returns some value, arguments are overridden, but only if value is a tuple of two elements, otherwise exception is raised. Let's see what happens when global hook is registered. I'm removing local hook and register global forward hook with always call set to true. Additionally, forward will always raise the error. The main difference between global and local forward hook is that the information is stored in a global collections. There is also no support for prepend flag. This time, global hooks is not empty, so let's fast forward to inner call. Remember that inner is called in try except block. Soon as forward is called, value error is raised. Except block process global forward hooks first. Only if the hook is stored in always called collection, it's time to invoke it. The hook is called as usual, except that in the presence of error, y representing result is none. If hook returns any value, it will be passed as a result to the next hook in sequence. In our case, the list is empty. In the end, value error bubbles up. In this video, I showed the details of forward in PyTorch module. Now you know. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.